So this video is more mental math and just a sort of a summary of multiplying and dividing by a bunch of common numbers. So let me go through some multiply ones. So multiply by 2 should be pretty straightforward, right? Think of just doubling things, right? I don't know, so even 2 times 43, right, is 86. This is a nice just place value type of thing without any rebundling. By 4, it should also be pretty straightforward. Let's say I have 4 times 24. So that's 2 times, let me do the, I don't want to do it, multiply like that. 2 times 24. So that's 2 times 48, which this may be a little tricky, but you can think about it. It's 2 times 50, but it's close to 2 times 50, but you're 2 shy of that, so 2 times 2 shy of it. That becomes 96. Things like that. All right. Multiplying by 5, typically what you want to think of is you can multiply by 10 and then halve, or the other way around. So let's say I'm doing, say, 46 times 5, right? So one way to think about that is that's 46 times 10 over 2, which is 460 divided by 2, which is 230. So that's pretty helpful. Okay. And then by 9, so really we're going to use the rule, so 9x is 10x minus x. And in this respect, I do mean like the variable x in terms of algebra type of thing, not times there. Right, and so this is the key thing. You hopefully know 9's within 10, and I talk about like the fingers method in one of the homework problems type of thing, but we can do this for other things. So for example, let's do 9 times 31. Oops. 9 times 31, right? Well, that's 10 times 31 minus 31. 10 times 31, so that's 310 minus 31. Okay, so you might need to think a little bit about that. However, one of the things to do about this is maybe a little compensation with that. If I subtract 1 off of both, 309 minus 30, that's 279. So that's an example, right? So there's a bunch of stuff going on in here. Let me walk this through again. So 9 times 31. So I'm going to use this. I'm going to do 10 times 31 minus 31. So 10 times 31 is very straightforward, 310, right? Minus 31. So now this would be the subtracting 1 off of both. Compensation. So I get 309 minus 30. Remember, if you're doing this, you want to make the subtrahend, the second one, easy to subtract. So I got 309 minus 30, and 300 minus 30 is like 30 minus 3, or 27. So 279 is what we get. All right. Okay, by 10 is easy, right? 10 times 65 is this, say, add a 0. And then the last one I'm going to do is by 25. And typically, if I multiply by 25, I can think about either multiplying by 100 and dividing by 4, or the equivalent, or dividing by 4 and then multiplying by 100. So let's say I have 90, let's do 92 times 25, okay? So in many ways, I would think about this in the compensation way, which is what I'm doing is moving 4 this way. So 92 over 4, that might be a little bit of a head scratcher, but it should be 23 times 100. All right, so that's 2300. So, okay. So that's multiplying. Let's talk about dividing. So dividing, we have fewer things. If I'm dividing by 4, I want to divide by 2 twice. So let's say 48 div 4, right, is really 48 div 2 divid 2. Right. And half of that is 24, and half of that is 12, for example. This would be one that you probably should know anyway. 4 times 12 is 28. But this sort of illustrates your thinking process with that. So by 5, I would do some compensation with that. I've done some examples with this. Let's do, say, 315 divided by 5. Okay. And this I would do multiply by 2. So the compensation for division, remember, you can either multiply or divide both by the same number. So if I multiply this by 2, it'd be a little bit tricky, but think of it as 300 plus 15. So 300 times 2 is 600, 15 times 2 is 30, 630 divided by 10, which is 63. Okay. By 10 is fairly straightforward. Right, we're just going to lop off the 0. So 6340 div 10 is 634. And then the last one would be divide by 25. So let's say 775 div 25. Okay, to me there's a couple of ways of doing this, and it depends on all sorts of things. Well, it depends on, not all sorts of things, a couple different things. You could either divide by 5 twice, if that was easy. This one doesn't look like that, so we'll often maybe do compensation with this. So again, if I do a multiply by 4, okay, this might be a little bit tricky. I'm thinking about this as 700 times 4 plus 75 times 4, which is what, 2800 plus 300, right? And then I'm going to divide by 100. So what did I do there? I'm thinking about this as 700 plus 75, and so this is distributive. I'm going to multiply the 700 by 4 to get 2800, 75 times 4 to 300, right? So 3100 div 100 is 31. Okay. All right. So, so with this, this sort of wraps it up. And this is one of these things where there's a couple of reasons that make the mental math pretty hard. The first thing is that everybody's a little bit different with your thinking skills, and you sort of need to figure out sort of for yourself what works for you. And so this section, there's a lot of strategies involved. There are even more than I've given here. I've got a book I probably will bring to class this coming week that has a whole bunch of other ones. It's kind of a fun little read if you're into this kind of stuff. So that's the first thing. So there's a lot of strategies. You sort of have to figure out what works for you. The other thing that's really difficult is that there's no sort of step-by-step thing to do. If you're presented with a problem, how is it that I go about doing this? Some of this last stuff has some very common multiplying, dividing type strategies about what to do. But in general, you're presented with some problem and it's not really clear what to do. So, and I say this is really common sort of in mathematics anyway. You just need to, you sort of get good at this by gaining experience. Gaining experience is a couple things. So as a student, that basically means let's work a lot of problems. So just, so you're given a bunch in the written work this week. You're given a bunch in the online homework as well. Just go ahead and do as many as you possibly can, and you'll get better at it. Obviously ask questions and things to that sort. So that wraps up mental math.